Okay, now onto way more important things: the
Mm.
heavens and the things that are going on above us that require explanations from smart people. And we have such a person in tow. He is on hold for a moment, and we will bring him on in a second. I'm going to tell you who he is in case you don't know. I mean, you'd have to have been under a rock. You'd have to have been under a rock that hit the dinosaurs and knocked them out some a couple of 100 million years ago to not know that Professor David Block is an astronomer, highly sought after inspirational speaker. He's a professor of astronomy. He's also devoted over 40 years to encouraging people all over the world to look up and never give up. He speaks from the heart. He shares in depth lessons about the world of research that he's very much involved in. This morning, he's going to tell us about a green comet, which I mentioned, I think last week we spoke about it briefly on the show, but we don't know anything about this. Prof. Block does. But he's also going to tell us about his visit to the Arctic to see the Aurora, something I know that both Mash and Gord and I are all excited about this morning. So it is with great pleasure that we bring on none other than Professor David Block. How are you, Prof?
I'm looking up. How are you, Gareth?
Good. First of all, I'm very, very happy to see you in good spirits. I see you had the most incredible trip to the Arctic. Start with that and tell us what you got up to when you went all the way north.
Well, Gareth, there are no real words, to describe the awesomeness of the Aurora. Have you ever seen them?
Oh, no, Prof. I'm desperate to, though. Tell me about them.
Okay, so the idea is that you have the solar radiation from the sun, the solar wind, which travels in from the sun and hits our Earth's upper atmosphere, and it ionizes molecules. And you get these shows, Gareth, of light, and they dance in curtains of light. And wherever you look across the sky, I show my groups. I take groups once a year. I show my groups like this one, which is showing here. That's an image I took in the Arctic. It's my photograph. And the temperature was minus 15 degrees centigrade. But we're wearing special thermal suits, so you don't feel any of the cold. But here you can see the swirling, dancing curtains of light. Just look at those rays, Gareth, emanating upwards. The reflections of the aurora was so bright that evening that I looked up from our roof and you could see it's like rain. It's like curtains of light just pouring down above one's roof. Wherever you go, it's just the magic, it's the awe and the wonder. And it's part of what you said earlier to your listeners, Gareth, is it causes us to look up and not focus on $1 billion deals. Gareth, here I am standing in my Munich coat. You've interviewed me when I've been in these locales, and I'm standing, my hands are raised because I'm just saying, wow, this cannot be true. And I'd love to take a group of South Africans next year again in March to see those dance curtains. This is another view. Gareth, think of something so romantic like this. You're sitting in a little hut somewhere, right? And you've got this log fire blazing, and you've got some cold glue vine or hot glue vine, and you're busy sipping it, and you just open the door ever so slightly, and you see what you've just shown your listeners on the screen. It's just, I cannot describe the beauty of the Aurora Borealis, so named by Galileo Galilei in around 1610. But this is really top of my bucket list. I've even taken a group of 30 gynecologists who were desperate to go and see the Aurora. They needed something to take their minds off all the problems in theater. And they contacted me and said, Prof, please lead a tour with 30 gynaes. It was the most incredible experience. But Gareth, it's just the magic, just like you were speaking earlier about things to remember and magical moments. If you look for a magical moment, this is it. And I trust, Gareth, I could mention my website, which is just davidblock.coza, www.davidblock, one word, davidblock.co.za, and people can then reach me and contact me, and I'd love to take another group next year to see the aurora. It is something which very few people actually see like I see. Most people go on cruise liners, which is the worst possible way, Gareth, of seeing the northern lights for many reasons. There's light pollution, there's movement. I know exactly where to go in the
Prof,
Arctic. Yes.
I have to. I mean, this is first of all one of my favorite pictures of you I've ever seen, of you in your outfit here, looking up at the aurora. Now, is it always green? Because I've seen colors, various other colors. Is it just the camera? I mean, what do you see with your eyes that we can't tell from this picture?
Oh, I love that question, Gareth. Green is the predominant auroral color. Green is, but if you look at one of those other pictures which you brought up just a few seconds ago of the reflections of the aurora in the water, you'll see there's reds, you'll see the yellows and the green. Now, to the naked eye, green, that one, green is the predominant color. But if you look very, very carefully, the hues of orange, there's yellow, there's red streaking upwards. But the eye doesn't always see the yellows and the reds. Many people see predominantly the green. It just depends on the cones in your eye. Some people have got great eyesight at night. Astronomers invariably do, but other people lack that. But nevertheless, whatever the eyesight conditions are, it's that magic of simply seeing something that I can't
Prof,
really describe.
does it, when you're looking at it in person and you're actually standing under these lights, do they move? Is it almost like there's motion in it as well, or is it static?
So it's a complete orchestral symphony, meaning this. You look up once they appear, they can appear anywhere in the sky, but like this one, you can see it stretching right across my sky. In other words, it's stretching from east through to west. It's in a particular area of the sky, and then an hour later, it's in a completely different area of the sky. So it's not limited to one specific area of the sky. But when they come in like this scenario, which your listeners are seeing, your viewers are seeing, is lasting perhaps, say, 15, 20 minutes in this shape. Then there's another shape. Then there's yet another shape. It's like here you can see again, completely different to the shape which you had shown your listeners, your viewers earlier. And these are like dancing rays of light, whereas the others were spirals of light. And the interesting thing is you cannot predict what you will see next. But what I can tell you is where I take my groups to, it's often right across a huge swath of the sky. My wife and I, whenever she's been with me once or twice, I've been about 7 times. You can never predict what the glory of the aurora will be, and it's dynamic, Gareth, meaning it's changing second by second.
You mentioned the Aurora Borealis. Now, there is an aurora in the south as well, in the South Pole, or rather Antarctica. You could see that sometimes too. It's just not as hospitable a place, obviously, but what's the difference between the two?
So, Gareth, the principal difference is you've got the Aurora Borealis in the north, right in the Arctic. You've got the Aurora Australis in the south. The problem with the Aurora Australis is they are there, but there are no land masses and hotels to take people to go and view the Aurora Australis. The conditions are extremely hostile in the Antarctic. And of course, you've generally got floating wads of ice everywhere. There are no hotels there at all. So the only way you can really see the Aurora Australis as far as tourists go is by means of ships. And that, of course, wipes out everything because the ships are moving, the ships are not dark. You can't actually go to the Antarctic in the middle of the winters. The conditions are far, far too dangerous and everything's iced up. Whereas in Norway or in the northern swaths of our globe, you can travel and you've got magnificent hotels by day to stay in, to actually do, you know what we did, Gareth? Husky sledding. So you can actually go on your little sled and the huskies take you all along in the day. And then by night, you just come with me. We've got all the buses lined up, the minivans. We've got special gear to hand out to all of our participant members in the group. And, you know, the interesting thing is this, it's everyone. I haven't
Prof,
had one member who hasn't said, wow.
Prof, you also mentioned that you're doing it again next year. You want to take some people along with you.
Yes.
How frequently does the Aurora Borealis happen? Is it once a year? Is it random as solar flares? How often does it happen?
So that's beautiful. I mean, the aurora are happening all the time, but you have to catch the correct moment on Earth to see it. Let me explain. If I were to take a group to the Arctic in December is a month of much snow. The Arctic is covered in snow. There's so much cloud that you will not see the aurora. The aurora are happening above the clouds in our upper atmosphere, but there's so much cloud that you cannot see. So you look up and you just see a cloudy night. So you have to wait until the cloud coverage somewhat dissipates. I always choose the month of March. I know where to go, which is terribly important. But secondly, I need minimal cloud cover, meaning this. If I choose April, you've got what's called the midnight sun. So then it's too bright to see the aurora. March is the month that really just solidifies everything. I've never, ever not seen the aurora. I've been there about 7 or 8 times now already, and my groups have never not seen it. We can never guarantee it, but the point is March to me, certain dates in March are absolutely optimal in terms of cloud cover and also in terms of what we call the equinox.
Professor, I just have a quick one I'd like to ask you. You mentioned that you go to a specific spot
Yes.
I think in Norway, and that
Correct.
there is you said the northern hemisphere is more accessible for this, but my understanding is that Iceland's quite good for it. I know you get them in Alaska. Are there certain places that get infrequent occasional visibility and other places that have a higher visibility, or is it just sort of where it's more accessible in terms of tourism? Because I know you said light poisoning is an issue, so obviously you want to be away from a city, but what are the characteristics, like what are the top 3 destinations if somebody wanted to go and do this as a bucket list trip like I do?
Right. I would say without a doubt, try and come with my group. Try. I know exactly where to go. I know.
I'd love to. I'm in. Send me the details. I'll meet you there.
Good. No, your question is very profound. And there's something called the auroral oval. There's a part of our Earth where these high energy particles from the sun hit the Earth's atmosphere, and they create a sort of oval of auroral activity. And the idea is you want to be within the oval. So that's why I've never been to Iceland, because weather conditions, and also I want to be really at the heart of what's called the auroral oval. You want to be there where you've got a maximized chance of standing at or underneath the domain where particles from the sun strike the Earth's atmosphere. And that is in principally, not only, but northern Norway is right at the heart of what we call the auroral oval. So yes, you can see the auroras sometimes from Iceland, sometimes from Canada, and so on and so on and so on. But the best chances, and the point is this, if you're spending some good money to want to see the aurora, why not go to where the probabilities are the highest? And that's why I go generally, always in the past, to right into the Arctic Circle in northern Norway.
Right, Prof. Because we've got limited time here and there's a lot that I want to cover with you, everybody's going crazy about this Green Comet,
Yes.
which you've sent us this picture of. Now, obviously, this is a picture from one of the space telescopes. This is not what you would see with the naked eye.
Yes.
It is a rare visitor to Earth. You told me that the last time that this was here, there were Neanderthals roaming the surface of the planet. And the next time it comes along, who knows what humans will look like? Who knows if we'll even still be living here? But this Green Comet what do we know about it, and how soon before these pictures did they actually spot it? Because sometimes these things have a nasty habit of just coming out of some corner of the universe and taking us by surprise.
So I think what's very interesting, Gareth, are a few characteristics. First of all, it's green. Green is indicative of diatomic carbon and cyanogen. It's a very, very beautiful green color. Comets, of course, are not rare at all. But what's very interesting about this one, I suppose, is its period of 50,000 years. So this comet was last seen, 50,000 years ago by the Neanderthals. I mean, it's extraordinary when you think of that. And when you try and extrapolate into the future, just look what's happened in the last 200 years with regard to light pollution. Will we still be around? Will life still be around in 50,000 years time, given climate change? We don't know. But the point is this: it's a magnificent sight to behold. It's not really naked eye at all, and I'll explain that in a moment, where best to look for it. But the point is, the image you've just shown, yes, some are from space, some are captured digitally on Earth, but it's got this characteristic green hue. It also has magnificent tails. I've seen flares of one tail going this way, another tail going that way, and another tail going straight up. And I think what's very interesting is this specific comet comes from what we call the Oort cloud, which is right in the outer domains of our solar system. It's been pulled in by the gravitational force field of the sun from way beyond Pluto, and it happens to be making a very close approach to the sun and to the Earth. Now, what's very, very interesting is this. What is a comet? A comet is simply a dirty snowball of ice mixed with dust. That's all a comet is, a dirty snowball, if you imagine, of ice mixed with dust. When the dirty snowball comes very close to the sun, it starts vaporizing, and the outer layers of ice and gas start melting. And so what happens, Gareth, is you have these magnificent tails. This is by no means the most beautiful comet I've ever studied. I think of Comet Ikeya-Siki. I think, of course, of Comet Halley. I think, of course, of Comet Bennett, which I studied extensively, in fact, way back as a schoolboy in 1969. But nevertheless, it's a magnificent comet which was discovered at Mount Palomar, the ZTS, that's the Zwicky Transit Facility. It was discovered at Mount Palomar, which used to be one of the great observatories on our globe, no longer the largest by any means. But the point about the comet, I think, is this. The green color really sets it apart, as you like, in terms of glory and in terms of beauty, but not in terms of brightness. This is a binocular object. You're not going to just simply stand up and I'll tell you when to look up and see it. You really need a good pair of binoculars.
It's amazing. I'm really, these comets and things, they're not rare by any means. They're always comets and asteroids scooting by the Earth. But some of them are more dangerous than others. And this one passes by at a not too distant kind of trajectory. I think there are satellites that orbit further out than this. Is that correct?
Well, this one is, of course, still far. I mean, it comes into around 42 million kilometers. The satellites are far more local. So this is really still far out. But the point is, it's good that it's that distance, because we do not want any. I mean, how did the dinosaurs become extinct? The dinosaurs became extinct because a huge chunk of rock, perhaps only a kilometer in size, actually impacted the Earth and created those incredible, the wipeout, the total wipeout at the Cretaceous tertiary boundary some 65 million years ago. So this is in the order of millions of kilometers rather than on our doorstep. But nevertheless, it's within a close proximity in terms of astronomical jargon.
Gordo, I know you've got lots of questions. Go on.
Yeah, I just wanted to, and I think I have the understanding of this right, but I'm not confident enough to unpack it. The difference between a comet and an asteroid, and the difference, or a meteor, and the difference in danger that they possess to the Earth if they were to get too close, or actually.
That's really a brilliant question. So the idea here is that Meteors, meteorites can be very small. I mean, the general meteor showers we see, they might be pea-sized fragments of rock which enter the Earth's atmosphere. The asteroid belt is generally between Mars and Jupiter. And the point is, with meteorites and meteor showers, they're generally pea-sized, micro pea-sized fragments which enter the Earth's atmosphere and burn up. Comets, the tails of comets can span millions and more kilometers. They are extraordinary, especially as regards the spatial length of their tails. Magnificent to be able. The micro parts are the meteors, the meteor showers. Of course, generally, when we look up at the night sky and you see these burning up in your atmosphere, that's telling you something very different to comets. Comets, as I say, are generally millions or hundreds of millions or whatever miles or kilometers away. The meteors or the meteor showers, let's concentrate on the meteor showers, which are very visible to the naked eye often, are just pea-sized fragments of rock. The comets are really the creme de la creme of the dirty ice balls of snow and ice mixed with cosmic.
Might there be a rock at the center of all that snow and ice and dust, or is it typically is it characterized by being a ball of ice specifically?
Oh, that's beautiful. We sent a spacecraft to Halley's Comet called Giotto, and they're the most incredible photographs, I'm sure many on the net, of the very core rock of Halley's Comet. I remember it so well, seen through the eyes of the Giotto spacecraft. So you've got your dirty snowball of ice mixed with dust, but at the nucleus, at the very heart of the comet, you can often have very, very rocky substances. The Giotto satellite showed us, which went right to view Halley's Comet. So yes, it's not only a dirty snowball of ice mixed with dust, but right the nucleus of a comet. You've got the nucleus, you've got the head of the comet, you've got the coma of the comet, can often be exceedingly rocky. But what's very interesting about comets is this: they are pristine, meaning if we can analyze the constituent material of comets, you're looking at those very pristine chemical elements which were there when our solar system formed 4.5 billion years ago. That's the point about the comets. That are so a pristine chemical factory.
So, Prof, how did comets and asteroids come to being in our solar system? Where do they come from exactly?
So when our solar system is formed, you've got a tremendous amount of gas. A certain amount of that gas collapses under the gravitational force field. F equals g and 1 and 2 over r squared just collapses under the gravitational force field, creates the sun. Then you've got blobs, inhomogeneous blobs of gas mixed with dust, collapsing to form our Earth, Jupiter, Saturn, and so on. And there's some leftover material in this cooling down process from the primordial solar nebula. And that creates the additional set of comets and of rocky materials such as the asteroids, such as meteors, and so on. It's a very, very complex process. But if you want to unravel what is happening, what happened 4.5 billion years ago, you need to look primarily at the comets, because they are these travelers, they are these interlopers from the very distant echelons of cosmic space and of cosmic time, coming to visit the eyes of the Gareth Cliff viewers.
Prof, you know what? The way you talk about this stuff always gets me enthusiastic as hell. So, a couple of questions from the audience here. Why don't we get the Aurora here? Shouldn't we all be able to see it from our flat Earth?
Well, of course, tongue in cheek, I suppose. I saw that overseas. I've been just returned, and the flat Earth drives me crazy. It drives me crazy. And I think that there are just many proofs, so we don't want to go about the flat Earth here. But the point is, why can't you see the Aurora everywhere? Because they're attracted in by the magnetic poles of our Earth. The north magnetic pole and the south magnetic pole. Those are the domains in which the particles from the sun stream in. So they either hit near the north magnetic pole or near the south magnetic pole. So it's the Aurora Borealis, or south, the Aurora Australis.
Prof, are these comets and meteors and spatial bodies, even small planets, are some of them likely to be loaded with very precious metals and substances that we could mine at some point if we had the technology?
It's interesting, mining of comets. Certainly not in my lifetime or yours will this happen. But I think, to my mind, as an astrophysicist, what I like most about it is the pristine nature. In other words, try and get more of this stuff, analyze it in a laboratory, as my late friend, the late Mayor Greenberg did. Try and unravel the mystery of it all, how our solar system, it's like a detective. And you're going and you're seeing this little piece of evidence, that little piece of evidence, this little piece of evidence. Not so much mining. It's really mining of the mind of men and women who wish to understand these three questions. Why are we here? Where did we come from? And where are we going? It's that sort of thing. And it's the same thing with the Aurora, I suppose, just looking up.
So, Prof, is it safe to sort of wrap it up or summarize in this way, is to say, when the solar system was forming, there was a bunch of core or base materials that were then underwent a lot of really complicated processes to do with heat and gravity and started to transform into other things. And those other things are now what we now see as the main bodies, excuse me, of the solar system. But the comets are the bits that escaped those processes and are still hanging around as they were before everything else got changed and changed again and changed again.
Yes and no. The point about this is the solar nebula forms, and comets are part of the solar nebula, but they've remained on the outer echelons. They've remained on the outer outskirts of our solar system, so there's no contamination. They get pulled in by the gravitational force field of the sun, but they're all part and parcel of the very formation of our solar system. Then they get pulled in, like this Green Comet has, and that's when we see the flowing tails and so on. But they're all part and parcel of the wonder of the creation of the actual.
So we could look at the building blocks by looking at comets.
Yes, absolutely.
And
Now, Gareth, may I tell my listeners where to look?
Of course, please go ahead.
So, firstly, if anybody wants to contact me about the Green Comet or about the Aurora, just davidblock.co.za. I'd be very happy to answer questions, or on Facebook. But the point is this: I'm not sure if you can see this clearly. I'm just holding it up. But the point is, let's just see if you can see it clearly. On the 11th, which is in 4 days' time, on the 11th, you will be able to do this. Look towards the east. Take a pair of binoculars. You'll see a very, very bright star. It's not actually a red star. It's the planet Mars. So you've got an immediate marker. There's a very red planet, the planet Mars. And take your binoculars and just move around the planet Mars on the 11th, the 10th and the 11th. And if you sweep like this, just by gentle circles, you'll see the Green Comet. That is, I would say, about the 11th is probably optimal for people to find it.
Prof, you have been absolutely invaluable this morning. For everybody who is not looking up, you've given us a reason to, and I'm thrilled that we could be with you for some time this morning. You've always got something interesting to add, and I loved your stories about the Aurora Borealis as well. Trips and all that information you can find at Professor David Block's website, davidblock.co.za. C-O-Z-A. There we go. Make sure you go and check it out. Thank you, Prof. It's always good to see you.
Thank you, Gareth, and mazel tov on your move. We are so proud.
Well, pop in. I think there's still too much light pollution for your like, but we'll have to go out into the Karoo somewhere to be able to get the conditions.
Well, let me end off with this. There's light pollution, but each one of you are unique and irreplaceable. You are made of the veritable stuff cooked in the interiors of stars, cosmic stardust. There's only one Gareth Cliff. There's only one.
Okay, Prof. Thank you so much. Lovely to see you. Professor David Block, everybody. Wow. Pretty
Thank
inspiring.
God there's only one Gareth Cliff. Imagine a troop of you causing crap.
I'm in the process of trying to clone myself as we speak, so don't jinx it.